of helium, the next higher element, He23. Now, it's good to remember some of these examples and their importance. Now, beta emission can also occur in another form. You see, a negative beta is emitted when a neutron degenerates into a proton and an electron. In a similar way, a proton can degenerate into a neutron and what? A particle that carries a positive charge. Well, that is also possible. So beta emission can also occur by the emission of a positive electron, and we call such an electron a positron. A positron is the opposite of the electron, has the same mass but positive charge. Now, a proton can split into a neutron and a positron. The neutron will stay back in the nucleus and the positron will be emitted as a positive beta. So a proton degenerates into a neutron and a positron. In this process, it will also emit some massless particles called the neutrino. Well, I'm sure some of you have some idea about these neutrinos. Now, in actual fact, the whole universe is assumed to be full of these particles, massless particles called a neutrino. The universe is actually swarming with neutrinos. But we don't have time to go into that direction at the moment. So look at what can happen in the nucleus. A proton splits into an electron with a positive charge, leaving behind a neutron and another particle, massless particles called neutrino. Now, as a result of this, a positive beta emission results in Z decreasing by 1 because that nucleus has lost one proton. One proton has become a neutron and a positron. The number of neutrons increased by 1, but the number of protons is decreased by 1. That means a positive beta decay results in the creation of the nucleus of the element one step below the original element, but the mass number remains the same. An example is copper, atomic number 29, mass number 64, emits a positron, a positive beta, leaving behind the nucleus of nickel of atomic number 28, one less than copper, and the same mass number. And in the process, you also have a neutrino emitted in that nuclear reaction. And we can represent that by this nuclear equation. I'm sure you are now familiar with how to write these nuclear equations. Another example is sodium of atomic number 11 and mass number 22 emits a positive beta, becomes a nucleus of neon of atomic number 10 and mass number 22. Now, we talked about two types of radiations, alpha radiations and beta radiations. Now tell me, what are alpha radiations? Alpha radiations are helium nuclei. They're made up of 2 protons and 2 neutrons. The emission of an alpha particle will result in leaving behind the nucleus of an element of atomic number 2 units less and mass number 4 units less. Beta radiations can either be positive electrons or negative electrons. Now remember, most of the beta radiations that we will be discussing will be negative electrons. So unless we specify, we would understand a beta radiation as a negative electron. And as a result of a negative beta, you will produce an element that is one step higher in the periodic table, atomic number 1 higher. Okay, what are gamma radiations? We already know what they are. They are very high energy electromagnetic radiations. Now, gamma radiation or X-rays frequently accompany the emission of alpha and beta radiations. Now, remember, the radiations take place in order to create stability in the nucleus. That means throwing away extra energy. You see, the extra energy inside the nucleus is what creates the instability. Throwing away that extra energy. And most of that energy is carried by these emitting particles, alpha, beta, and also these gamma radiations. Well, we have already looked at these pictures already. These gamma radiations are not deflected by electric or magnetic fields. But none of the electromagnetic radiations can be deflected by electric or magnetic fields. These gamma radiations is able to travel many meters in air and many centimeters in human tissue. In fact, it readily penetrates most materials. Well, that brings us to the question of how damaging these radiations are. Alpha radiations are very massive. That means as they go through air, they will be colliding with air molecules. That means they will stop very fast. Beta radiations are very small particles. That means they will not be stopped as readily as alpha particles are. But gamma radiations are very high energy electromagnetic radiations. They can go right through in air for a long distance. Now, radioactive materials that emit gamma radiations and X-rays constitute both external and internal hazard to humans. So when we talk about the hazardous radiations, mostly we are talking about gamma and X radiations, which are very harmful to the human tissues. Well, that doesn't mean the other radiations are not. Alpha and beta are also damaging. Now, dense materials are needed for shielding from gamma radiations. In fact, gamma radiations really cannot be stopped by thick clothing. Now, strong gamma radiations can be stopped only by thick lead sheets. Now, here I have a piece of lead. This can stop most of the gamma radiations. All right. So that takes us to the relative penetration ability of radiations. Which of these radiations have greater penetrating ability? Well, obviously, we know alpha radiations do not penetrate much, but gamma radiations are very highly penetrating. Alpha, the least penetrating form of radiation, can be stopped with a piece of paper or a few inches of air. So they're not very highly penetrating. Now here I have the relative penetration abilities of these materials. Alpha radiations can be stopped by a thin layer of paper. But beta radiations cannot be stopped by a thin layer of paper. They can travel very many meters in air and can be stopped by a sheet of aluminum. In fact, I have a number of materials here which can be used for, I have a box of materials here which can be used for the penetration ability of these. Here I have aluminum that can stop alpha and beta radiations. Well, I have a sheet of aluminum, thick one. Well, depending on the energy carried, you need different thickness. I have different thickness of aluminum to study the penetration abilities of different beta. And of course I have a lead which can stop the gamma radiations. So higher the energy carried by these radiations, the more difficult to stop them. So one of the characteristics of these radiations are they have different penetration abilities. Now, what other thing can these radiations do? You see, one of the things that I have not mentioned in the PowerPoint maybe, but I'm going to mention that briefly. When these radiations pass through certain medium like air or any other material, they can actually produce ions. Now, what are ions? An ion is an atom that is missing some electrons. Now, let me see if I can draw a small picture of the atom on the board before I explain. Well, the picture of the atom we have now is that you have a nucleus that is positively charged and electrons in shells or subshells in a region surrounding the nucleus. Now, this is a neutral atom. Now, if some extra energy comes from outside, like in the form of an alpha particle. Suppose an alpha particle whizzes through air and it happens to hit that electron. That electron can be ripped away from the atom. That means this atom now contains one electron less. That means it carries an excess of positive charge. This is now an ion. So an ion is an atom that is missing some electrons. And these electrons can be ripped off the atom by subjecting an element to these radiations. That means these radiations are good ionizing agents. What is an ionizing agent? An ionizing agent is something that generates ions. Now, which of these radiations is a better ionizing agent? Alpha, beta, or gamma? Well, because alpha is massive, along its path, although its path is very limited, along its path it can knock off electrons from atoms much more readily than other radiations. That means alpha radiations are very effective ionizing agents. Beta radiation also can produce ions, but not as effective as gamma, as alpha. But gamma radiations are very poor ionizing agents. So you can see, as the penetration ability increases, the ionizing ability decreases. Or as the penetration ability decreases, the ionizing ability increases. That is something that you must know of these radiations. All right.